Okay, so this is version 2.6 of Tycho, which has just now recently been released. So to get started, this version adds support for an offline local copy of the DO2 catalog. It also adds support for automation, midpoint tracking, and overlays. So let's go ahead and go over each of these features in more detail. As you might expect, the offline DO2 catalog is a fairly large download. It comes in at 40 gigabytes and it extracts out to 60 gigabytes. So it does require a fairly decent internet connection, and if you are interested, it is available here at this link. It has also been provided by Mark Serow and the Gaia team, and they do ask that if you publish work using this catalog that you provide credit to them, and they have a README file on how to do that. The next feature is automation support. So what this means is that Tycho can now be run from the command line, and the way this works is that if you have a script, for example, you can update what's called an override file. This override file contains settings on how to run the tracker. So when run in this fashion, the Tycho software will automatically generate and save the tracks for later review, and this is an especially nice feature for those who wish to conduct automated sky surveys. The next feature is midpoint tracking. Originally, Tycho used to stack all of the exposures relative to the first image, and what this meant was that the object in question therefore had to be visible in the first image in order for it to be detected. This is now no longer the case with midpoint tracking. Instead, the images are now stacked relative to the midpoint of the exposures, and so this is really nice for those who conduct follow-up observations of NeoCP objects, because now you no longer have to know exactly when the object will enter the field of view. The next feature is the ability to overlay information on the image viewer. So for example, in the upper right corner, we have information about the observation, such as the coordinates of the object, the magnitude, exposure time, and the date of observation. And in the upper left corner, we have information about the track. So the label of the object is 2000 RZ92, speed and position angle. In the lower left corner, we have information about the observer, the measurer, if available, station code, telescope, and plate scale. And finally, in the lower right corner, we have a magnifier. And all these settings can be adjusted: font size, what information to include or exclude, zoom level of the magnifier. It is all adjustable. So finally, we now have a demonstration. I'm going to take a known NeoCP object, 2018 UC2, and I'm going to go ahead and run the tracker on it. I've done this before already, so I already know what values to use. And the purpose, again, of this demonstration is just to show off the newer features. So I'm not going to go into all the details and how to run the tracker and that sort of thing. But let's go ahead and wait for it to finish up here. And as you can see, it detected the object just fine, even though it was outside the bounds of the first few images. So it looks like these first few images here, the object was not visible in the field of view. But again, with midpoint tracking, that is no longer a concern. The object was tracked just fine. Okay, so let's go ahead and create observations of this object so I can use my offline DO2 catalog. So it's very quick, and I can optimize and verify the track. So I'm going to go ahead and create observations of it. Initially, you just see one overlay here, but when I add the observations, it has more information. So as you can see, we now have additional information on the object, so date of observation and so forth. And again, this is customizable, so if I wanted to, I could choose what overlays are available. I could also change the font. I could change the font size. And I can also choose what information is shown in each overlay. So if I want to have the measure shown, I can do that too. Okay, so now the next feature I'd like to show is the automation. So let's take a look at that. Okay, so at this point I'm going to go ahead and demonstrate the automation module of Tycho. Now, before you do this, I recommend running Tycho manually, just to get an idea for what kind of settings work for your setup. But in any case, once you're confident that you're familiar with how to run Tycho manually, then you can go ahead and try out the automation. So auto run is what the module is called, and there are a variety of settings here, but they're broken into 4 quadrants, if you will. So runtime settings, these indicate whether or not you want to perform alignment on the images, normalization, whether or not to close the program when it's finished, that sort of thing. Output is how many tracks do you want to identify, or verify, if you will, as well as image contrast and intensity. So when Tycho runs the automation process, it also creates snapshots of each object. These snapshot images are used, for example, if you are running Tycho in a remote location with poor internet connection, you might not want to have to download the large raw images. Instead, you can just simply download these snapshot images for verification, and if you see something interesting, then you could pursue it further. But in any case, for this demo, we will do 100 tracks to verify, and we'll use these settings: limit speed PA 0.3 to 1 arcsecond per minute and 230 to 300 degrees. If we wanted to do a full search, we just simply uncheck these boxes. Okay, so if we're happy with these settings, then we can create an override file. And what this means is we can specify the tracker settings using a text file. So I have simply copied those parameters into a text file, and when Tycho sees that there's this override file adjacent to the input directory, then it will run the tracker using those settings. So you can simply, if you're running a script, you can manipulate this file very easily to adjust the settings as needed. Okay, so here's what my script looks like. It's a batch file, and it's very simple. I just say, here's Tycho. We want to run Tycho with this input directory, and when Tycho runs, it will notice that there is, in fact, an override file. So let's go ahead and take a look at that. So I'm running my batch file here, my script, and as you can see, it's starting the alignment process because I wanted to go ahead and do alignment on these images. And this takes a bit of a while, so I'm going to take a quick pause on the video. Okay, so it's finishing up the alignment process, and as you can see, once it finishes that, it automatically moves to the next step, which in this case is normalization of the images. And once it's finished normalization, the step after that is to perform plate solving. So as you can see, this is a fully automated run here, and I've not had to do anything on my part. So once the plate solving has finished, then it will begin the tracker. So let's go ahead and see what that looks like. Yeah, as you can see, it has already started the tracker. And this is another part that takes a few minutes, again, because we're of the settings we have. So I'll go ahead and take a pause on the recording. Okay, so the tracker has just now finished, and it's on to the next step, the first of which here is to optimize the track. So as you'll recall, for the auto run settings, I specified 100 tracks. So that's what's going on here. And now it's verifying these 100 tracks and creating observations of each of them. And it is also creating the snapshot images that I mentioned earlier. And so, again, it's going to do that for the first 100 tracks. So let's go ahead and wait for it to do that. Okay, so now it's finished and it has closed the process. And if you wanted to look at the log file, you could do that. But what I'm going to do here is I'm going to show you the results. As you can see, it generated these output directories. It aligned them, then performed normalization, and then finally created the output tracks. So in this directory here, we have 100 tracks that have been created. And so the first one, for example, has the observations that were generated for that track, as well as the snapshot images. So this is zoom level 2 and then zoom level 4. and then we created 3 stacks. But to actually make better use of that information provides a way to do that. What we can do is load up the tracks without those fits images and simply look at the snapshot images. So in this case, if I were to, let me go ahead and do this first. If I were to go ahead and do some analysis on them, for example, if I wanted to verify the track, what you now see is a snapshot viewer. So the snapshot viewer is just simply going through those images that were created, and you can choose what zoom level you want. Anyway, if you do tend to think that this is in fact an observation, an object of interest, then you can add observations. And again, it's actually using the observations that have been generated previously for this object during the automation routine. So I can go ahead and go to the next object, add observations, and so on and so forth. So so anyway, it works very nicely, and again, this permits you to perform inspection of the data remotely. So it's another feature, and I'm sure I will add additional facilities to it, additional improvements as it progresses. So anyway, that's how automation works in Tycho, and so thanks for watching.